In project planning, few concepts are discussed as frequently and misunderstood as often as the critical path. The critical path method, or CPM, is not simply a calculation that highlights activities with zero float. It is a project management technique that provides visibility of the sequence of activities that directly controls the project completion date. A well-developed critical path allows project teams to answer fundamental questions such as what activities truly drive the completion date, where should management attention be focused, which delays will impact the project finish date, where is there flexibility within the program, and are mitigation actions targeting the right areas. However, the value of the critical path depends entirely on the quality of the program logic, constraints, calendars, and planning assumptions behind it. A Primavera P6 program can always display a critical path, but that does not mean it represents the true project risk. Understanding the critical path begins with its definition. It is the longest sequence of logically connected activities through a project network that determines the earliest possible completion date of the project. The word longest is important. It does not refer to the activity with the longest duration, the most expensive activity, the most important activity from a stakeholder perspective, or the activity with the highest resource requirement. Instead, it refers to the longest chain of dependent activities based on their duration and logical relationships. For example, consider activity A, then activity B, then activity C, leading to project completion. If this sequence takes 100 working days and all other paths take 85 days, then the A to B to C sequence controls the project completion date. Any delay to activity A, B, or C will directly delay the project finish unless corrective action is taken. The mathematics behind the critical path involves two main calculations. The first is the forward pass. It calculates the early start and early finish, determining the earliest possible dates activities can start and finish based on project logic. The formula is early finish equals early start plus activity duration. The forward pass begins from the project start date and moves through the network until reaching the project completion date. The second is the backward pass. It calculates the late start and late finish, determining the latest dates an activity can start or finish without delaying the project completion date. The formula is late start equals late finish minus activity duration. The backward pass starts from the project finish date and works backwards through the network. The difference between early and late dates gives the available flexibility, called total float. The formula is total float equals late start minus early start, or total float equals late finish minus early finish. Activities with zero total float are normally considered critical because there is no available time contingency. However, this assumption requires caution. A common misconception is that any activity with zero float is critical. In reality, zero float can be created artificially by hard constraints, incorrect logic, poor program structure, excessive use of mandatory dates, incorrect calendars, or artificial deadlines. For example, applying a constraint such as start on the 1st of July can force an activity to become critical even if it is not genuinely driving the project completion date. This creates a false critical path. A planner should always ask whether this activity is critical because of the project logic or because of a planning assumption. Primavera P6 provides several ways to identify critical activities. The correct method depends on project requirements and reporting standards. The first method is to define critical activities based on total float. This is the most common approach. In Primavera P6, you go to Project, then Activities, then Filter, then Critical. The planner can define critical activities based on total float less than or equal to a selected value. For example, total float less than or equal to 0 days identifies activities that have no available float. However, many organizations use a different threshold, such as total float less than or equal to 10 days, to identify near-critical activities that could become critical with minor delays. The second method is to configure critical path settings in P6. To define how P6 calculates critical activities, navigate to Enterprise, then Projects, then Schedule Options. Under the Critical Activities section, planners can select total float less than or equal to define the float threshold. For example, 0 days gives a strict critical path, 5 days gives high-risk activities, and 20 days gives a wider management focus. The selected value should align with project reporting requirements. The third method is to schedule the program correctly. Before trusting the critical path, the program must be calculated. In Primavera P6, go to Tools, then Schedule, or press F9. Ensure that the data date is correct, open ends are reviewed, logic is complete, constraints are understood, and calendar assumptions are correct. Then review the longest path, critical activities, and total float values. One of the most misunderstood areas in P6 is the difference between critical path based on float and the longest path. Critical path based on float identifies activities where total float is less than or equal to a defined threshold. The longest path identifies the chain of activities that mathematically drives the project completion date. In complex programs, these may not always be identical. A program may contain multiple critical paths, negative float, constraints affecting float calculation, and multiple completion milestones. For major infrastructure projects, using the longest path option can often provide a more reliable view of what actually controls completion. Common critical path mistakes in project planning include treating the critical path as static. The critical path changes throughout the project. A delay to a non-critical activity may consume its float and move it onto the critical path. The critical path should therefore be reviewed regularly, not only during baseline approval. Another mistake is focusing only on current critical activities. A planner who only monitors today's critical activities may miss future risks. Near-critical activities should also be monitored. For example, Activity A has 0 total float, while Activity B has 3 days total float but a duration of 90 days. Activity B may represent a greater future threat because a small delay could immediately impact completion. Another mistake is using constraints to control dates. Constraints should be used carefully. Overuse of start on, finish on, mandatory start, or mandatory finish can hide genuine program logic and create misleading float calculations. A logically driven program should explain dates through relationships, not artificial restrictions. Project planners should use the critical path to support decision-making, not simply for program reporting. A strong planner uses it to identify risk by asking what activities have no recovery opportunity, where delays are most likely, and whether resources are allocated appropriately. It helps prioritize management attention. Not every activity deserves equal focus. Critical and near-critical activities require more frequent progress reviews, stronger ownership, early escalation, and recovery planning. When delays occur, the critical path helps evaluate which activities can be accelerated, where float can be used, and which sequence controls completion. The critical path is one of the most powerful tools available to project planners, but only when it is understood correctly. Primavera P6 can calculate critical activities in seconds, but producing a meaningful critical path requires professional judgment. The real skill of a planner is not identifying the red bars on a Gantt chart. It is understanding why those activities are critical, whether the logic is credible, whether float represents genuine flexibility, and how project decisions should respond. A reliable critical path is not created by software. It is created through robust planning, realistic logic, disciplined governance, and continuous review. The best planners do not simply report the critical path, they manage it.